Hi everyone, welcome back. In my tutorial series, we were talking about the object detection modules, and lastly we learned about DNN-based face detection and recognition. And in this video, I want to make a combination of these two classes, which is this module is including face detector and the face recognizer. So with the help, at the end of this video, I'm planning to give a reference image to the code, and according to that reference image, reference face is gonna tell me in a real-time video. For example, I'm gonna use my computer webcam, so it's gonna tell me and this reference face exists in the current frame or not. So we are gonna kind of make a verification. Also, in another AI based model we already checked in, also you can find in my YouTube videos. There is also another method which is recognizing, which is verifying the faces accordingly. But in this video we are only gonna use these two classes. Also in here you can get the models. There is already here, I think there is a link in here maybe. Okay, in here you can get the models, all of them. For example, this Onyx format models, since we are using C++, this Onyx format models we are gonna need. Also similarly for the recognizer, you need a model which is in here. I think we can get, yeah, here there are two kind of Onyx format. You need to get these models. So I already downloaded. Also, I'm planning to use these faces. Let's say, for example, I'm gonna give my face as reference image, reference face, and it's gonna detect, it's gonna get the features, and I'm gonna open my webcam and it's gonna detect I'm in the video or not. Okay. Let's start. Also, I want to code from scratch. Maybe people are directly watching this video, so they can easily continue with the wire on this video. So first of all, we are gonna start with the defining the model path, the easiest part, which is just string detection model path. Just we are typing, and this is gonna be basically my detection model, which is this one. And also similarly we need a path for the recognizer model path. Okay, and this is gonna be the path of the recognition Onyx model. Okay, after this is done, the next step is gonna be just defining some method we are gonna need. For example, we are gonna need reference image. Also, we can directly define in here, just here, CV imread. So this is gonna be our reference image, which is comparison images. As reference, this code is gonna take this image. So here we can put my image, this one. And after this is done, the next, I think first of all we can done with this image, then we can continue with the other which is gonna deal with the real-time video frames. So first of all, we can deal with the reference one. So all we need to do is just first of all calling this pointer, gonna be the face detection. Also, people who are needed to get the details of this detector and the recognizer class, they can check from my tutorial series also. Okay, this is gonna be the detector reference we can call. And it's gonna, we just need to call detector create. Okay, in here we need to give the model, which is detection model, and also we need to give config can empty for now, and also the input size. According to my reference image sizes, I can give the size of 320 to 320. This is most of the cases if you are not working with really low resolution cameras. This is gonna work, I believe. Okay, after my detector is done, I need to set the input size, which is the network size. So for that, I just need to call detector reference dot set input size, and this is gonna be this is important, otherwise it can cause to crash. This should be the same size with the input image. And after this is done, basically we can just call the detect function here, and it's just need to take the reference image, and it's gonna give me an output, which is which is including the faces, and in there maybe we can define more maths in here, which is gonna be face reference. Okay, then I need to give this into here, and I get my face from here. I'm gonna get, okay. And once this is done, we can switch to the recognizer class. We can at least create it similar way to the face detector. So just recognizer, and this is gonna be the recognizer but for reference, and we are gonna create in the similar way, and it's gonna get the recognizer model path and just config. It doesn't need a size. Okay, once this is also done, now we can this is gonna handle the reference image, and it's gonna get the, first of all we need to crop the face via on this detection, and after that we can just align it, and we can get the feature. So first of all we are gonna get the feature at the end of here, then we all we need is just the features of the reference face. Then in the real-time video we are gonna basically just gonna compare that feature with the incoming feature. So according to that incoming feature, there is gonna be a comparison. Then according to that, it's gonna verify, or it's gonna tell this is not the similar face to the reference image. Okay. Here we need to, first of all, recognizer reference. Just we need to call align crop. Here the input image is gonna be this time reference image again. Okay, and here we are gonna give the face points also somehow. So this is gonna face reference, but this is gonna be the first. So I'm in here, you need to be sure your input image is including reference image is including a face. Otherwise in here, if the face reference doesn't have an input, since I'm already sure there is a face in there, and this is gonna include a face, so I'm getting the first one because there's only one face in there. So you need to be sure which coordinates, which face you are giving as input to this recognizer class. So that's important. And once this is done, the next we are gonna need one more method, which is gonna be the, since it's gonna give an aligned face, aligned reference face, and here I need to give this as input, and it's gonna give me the output accordingly. Okay, once this is also done, next step is gonna be finishing recognizer reference. Just give me the features. Also I need again feature reference here. So I need to give the aligned face into this feature because it also says here aligned face is needed. And after that I need to give feature reference, and I'm done in here. So basically until here we detected the face, reference face, and also we get the feature of that reference face including. Okay, so we already get feature in here. So we are gonna use this in the loop, in the video capture coming up the frames. We are gonna use for each frame for the comparison, this feature reference is gonna be used. Okay, this is done. The next we can maybe create the detector for the global, which is gonna detect the incoming faces. This should be different because if your objects are same, you can get some errors. We already talked this in the tutorial part series, you can check in there. So I suggest both objects should be different. So this is gonna be detector global, let's say, and it's gonna use the same model path and the same size. Okay, there's no problem until here. And the next we can directly also set input size, and this is gonna be but this should be according to my camera size, so I don't want to do this in the for loop. Just I can basically call the size in here also I suggest before entering to the for loop, maybe you can handle here. So I just know my camera sizes, which is 1280 and 720. So since I already know, I'm already setting the input size in the for loop, I don't want to do again and again because this should be done once. Okay, and also this is done. The next, also we can create the recognizer similar to the here recognizer global. Okay, here also, what else? Nothing else. Okay, recognizer also done. The next, we can call our video capture class for the video stream. Okay, I'm gonna use my camera. You can use any video if you wish, and there is need a while loop. It can be infinite. Now I can get I can get this into an image, or okay, let's frame, maybe we can call. So I want to get each frame in the here. Also maybe we can create a name window so we can resize easily. Frame we can call, and just normal window which is 0 index. Okay, once this is done, we can continue via on the first of all we can detect the face, so we can call the detector global and just call the detect function, and here I need the image which is frame, and which is frame, and the next is gonna be the faces. So maybe we can write that here, faces global. So in each loop it's gonna be refreshed, faces global, and it's gonna detect the faces in the image. Next we are gonna continue with the recognition, but before that maybe we can just make a simple example to see is detecting successfully my face or not. So for each face, just calling the faces global dot rows and just a plus plus. In here I'm gonna get into the reach to each box of the faces. So here I need to call a rectangle, is just maybe box we can call, is gonna keep the coordinates, or we can simply just create like this, faces global dot add, since it's giving the output in the float type for accuracy, so we can follow accordingly. So it's gonna give basically these coordinates. The first one gonna give the x, the second is gonna be x, and the third one is gonna give the width, and the next is gonna give the height accordingly. So I get my face if exits my face box, and the next I want to draw it. Okay, rectangle, this one, frame, draw it into the frame, and box is my rectangle, color, which is gonna be our favorite color, yellow, and the next is gonna be thickness, let's say 3 maybe, line type not important. Okay, then the next I'm gonna make it imshow, and frame is gonna our window name, right? Okay, so the next frame, show me the frame, and maybe we want to quit with a key, just call a wait key, which is 1. If is equal to q, just exit, which is gonna make break. Also maybe better at the end of the anything, just release my camera in some cases. If we do not do this, it can cause some problems. Okay, all is done. Now I'm gonna try it. Let's try how it looks like. Oops. Okay, what happened? Up. Why it crash? Dup. Okay, what is wrong? I 0, 2, 3. rectangle and show me the frame I'm telling. Okay, why it doesn't work? In here, am I making a mistake? Maybe just close here. At least I will just want to. Okay, now it's working, so it means we are making a mistake in here, in this part. So what's the issue? Detection model we are giving as input, and also after that we are setting input size, and we are keeping the, I think here shouldn't cause the crash. Let's see. Okay, it doesn't cause crash. And here I'm recognizer model I'm giving. This recognizer is creating. Okay, this shouldn't also cause crash. Faces reference. Okay, here we are making mistake. It is not face reference 0, it's just rows 0, not rows, row. Okay, this should work now. Okay, now basically we are just using the detector first of all, not the reference image we are considering. We are quitting with the Q. Okay, now all is fine. After the detection, I want to now calling my recognizer, global recognizer, which is in here. So this is gonna just similarly as we did in here, just it's gonna call this one. Recognizer global is gonna be also the feature, and after that it's gonna get the face global row 0, and it's not gonna take the reference image. Oops, it's gonna get the frame. Okay, faces global aligned reference face. We need one more, which is gonna be aligned global face. Aligned global face. Okay. So we need to copy it. Feature reference, feature global we need also, which is similar to here. Feature global. Okay, and just copy it into here. This also should be global. Now all is global, right? Okay, here not yet. This is aligned global. Okay, this is gonna align the face and gonna give that as input to this feature. But here important, it should only enter here if the face global exists. Dot rows. Okay, this if this is bigger than 0, otherwise it means it cannot detect the face, so do not enter here. So just make scope in here, and here is done. I think now we get the features. Now we can calculate the result, double result. I'm doing here according to the this recognizer or cosine. Oops. Is there a here? There isn't. It does not saying, but there is a documentation in somewhere 0.3 maybe. It doesn't write, but if the result is 0.3, we are gonna use the cosine method. So if the result of this match function, which is gonna be this one, I mean recognizer global dot match. Okay, so the feature one is gonna be the feature reference, and the second one is gonna be the new feature, which is feature global, and the next one is gonna be the display type, which is the defaultly recognizer, defaultly the cosine, this one. So here, if you are using this method, the result, the double value, if the bigger than 0.3 something, it means the faces given as input are the similar faces, they are the similar. If otherwise, if smaller than the 0.3, it means they are different faces. That's the simple logic. Is the, you can write here 0.3 something. Okay, now I want to check if the face, the detected faces is the result. So by the way, we are just getting, by the way, 0. it means we are only considering in the incoming faces should be only existing one face, or we are only gonna consider the first one, because this is just example. You can modify according to your cases. I'm just gonna considering there's gonna be only one face in the incoming video, which is gonna be my face. Okay, in here result, if bigger than 0.3, my rectangle should be, my rectangle gonna be yellow. Otherwise, I wanna it to be red, which is not similar. BGR, which is gonna be like this. Okay, let's see. Also, maybe we can we can also put a text into the frame, like just put text frame, and text is gonna be the toString, which is gonna be result. Point is gonna be, let's say 50 to 50. What else? Font say, okay, this can be 1. Color can be yellow again. So we can also see in the screen which result we are getting. And I'm done. Let's try to run. Okay, now we are getting 0.5 something. Maybe we can make it bigger. Which was the font scale? Okay, this one. You see now me in the screen, it says 0.5, which is I'm similar to the given input. I have one more. Which one? This one. Don't know which one. I think this is gonna be maybe more similar to the current situation, because also I'm using glasses. You see, this is more similar to my current face. It's giving me more high results than the 0.3 means they are more similar. The meaning is that. So like that, this cosine. Let's give an Obama face as input, as reference image, and let's see the result. Okay, now you see 0 red, because it says you are not similar to the reference face. That's the meaning. Yeah, this is working very accurately. You see, faster also. Currently I'm not using a GPU, it's just using CPU, and it's really faster. I'm also using only OpenCV library, nothing else I'm using. The models also I'm using, which is OpenCV referring. So yeah, simply for this video I want to make, since we already learned these things, I want to make a simple project. You can adaptate this project any kind of things. Just back to this moment. Yeah, you see it's working perfectly. Yeah, I want also code from scratch. Even we got an error in here, we already checked together. Yeah, I'm done for this video. Maybe if you wish, I can put this into my GitHub. Yeah, if I forgot, even just mail me. I'm gonna send you the code. I'm done for this video. Thanks for watching. See you in the next videos.